All right, so today we're going to be doing assignment number 4 in our second unit. Um, this is on distribution shapes. And so just real quickly where we've been, the first unit was on qualitative and quantitative data. So qualitative data, if you remember right, is data that cannot be defined with a number. It's like your eye color. And then quantitative data would be either discrete or continuous data, but quantitative is data that is our numbers. So then we moved on to 2.2 and talked specifically about how we can display qualitative data. We talked a lot about frequency distributions and relative frequency distributions, as well as picturing those distributions with either pie charts or bar graphs, bar charts. And then yesterday we did assignment number 3, which was displaying quantitative data. So we can categorize data 3 different ways with single value grouping, limit grouping, and then cut point grouping. So single value grouping is just if the answer is just a single value, like the number of televisions you have in your house. Limit grouping is for discrete data that's the range is just so wide you would have too many single limits, and so you put them in groups. And then cut point grouping would be on a continuous scale. You just have to make certain cut points and put people in groups based on those cut points. And then we talked about how we can organize that information and display it with histograms, dot plots, and stem and leaf plots. And so today we're going to be talking about distribution shapes. So when we take those distributions, how are they shaped differently? And then actually much of this semester will be on just different distribution shapes, including especially the normal distribution, which a lot of times is referred to as the bell distribution or the bell curve. So that's what we're going to be going to today. And so distribution of data sets. The distribution of a data set is a table, graph, or formula that provides the values of the observations and how often they occur. So the shape is often classified 3 different ways. Classified by the modality, by symmetry, and by skewness. And so we're going to take a look at each of these 3 different classifications. The first one is with modality. So let's take a look first at this relative frequency histogram. And we're going to kind of, if we just take a look at the histogram itself, it's those different bars. Well, we can kind of approximate the bars with a smooth curve for the heights that kind of goes through the center of each of those bars. And so then we get kind of a shape that kind of shows the distribution. So this is really high distributed in the middle. And so there's a lot of people 63, 64, 65 inches high. Not so many people 57, 58 inches. Not so many people 70, 71, 72 inches. So we're really talking about that shape. And so if we talk specifically about modality, we can say it's unimodal. Unimodal means that there's one peak. Okay, there's bimodal, okay, which means there's 2 peaks, and then there's multimodal distributions, where there's just different peaks and valleys at different places within the data set. I would say that most of the time, data that we collect is unimodal. Okay, not often. As a teacher, it's nice to have unimodal data because that's where you'd spend most of your time teaching. If you have bimodal data, man, you have a group of people that really don't understand something and then a group of people that do understand it. And so where do you spend most of your time teaching? That's more difficult to do. But the modality is where are the peaks in the graph and how many? And then the second way that we can describe this is with symmetry. So we can say something is bell-shaped, okay, that kind of looks like a bell, centered in the middle. Okay, it's unimodal. Same thing on the left, same thing on the right. It is symmetrical. So another one that's symmetrical is triangular. Okay, just kind of goes up to the top and then starts to come back down. Again, it's unimodal. But you can see the difference between triangular and bell-shaped is that a bell-shape kind of starts out really slow and then shoots up, comes back down, and then kind of scoots along the axis again, where here it's more like a triangle. And then uniform. So uniform would be, man, there is no peaks and valleys. It's just kind of the same all the way through the data set. You have just as many people that are, if this is height, just as many people that are short as you do that are tall as you do that are right in the middle. Okay, so these three types of symmetry are things that we should know for this lesson. And then we also have skewness. So it could be skewed to the right. A lot of people get these backwards, but it's skewed to the right if it's looks like it's being pulled to the right. Okay, it's stretched way to the right. Skewed to the left would be if it's pulled way to the left. Okay, so if something is skewed to the right, most of the data is to the left. And if it's skewed to the left, then the majority of the data is skewed to or is at the right. And so that's, I think, why people get these kind of mixed up. But that's skewness. It's not symmetrical. It's either skewed to the right or skewed to the left. So then we have other shapes. We have the reverse J shape here, okay? And then we have the J-shaped distribution, which kind of just starts off really low in one area, and then as we get going and going, it gets higher and higher into either to the right if it's J-shaped or to the left if it's reverse J-shaped. So those are just different types of distribution shapes. And so let's take a look at some examples. Relative frequency histograms for household size. So you look here, there's a household where there's just one person that lives in a house, or two, or three, or four, or five. You can see that this is not symmetrical here. There's a lot more people where there's one or two people that live in a house than, let's say, 5, 6, or 7. If we put a shape to this, put a kind of a curve that goes along with this that matches this, you can see that it's unimodal. Okay, it's probably skewed. It's unimodal because there's one peak. It's skewed a little bit to the right because that's where it's being pulled. It's kind of close to being bell-shaped, but not really because it's not symmetrical. I would just say it's skewed to the right. All right, so we can talk about the difference between population data and sample data. Now you want them to be the same. You want the sample data to simply reflect the population data, but the population data is the values of the variable of the entire population. When we talk about sample data, those are the values of a variable for a sample of the population. Okay, and the distribution of population data is called the population distribution, and the distribution of the variable. And when we compare that to the sample distribution, that's simply just the distribution of a sample of the population. So there's a little bit of a difference there, but I want to show you how these are related to each other. So here we have the population distribution. So this is the number of people. Here's a relative frequency, and this would be like the number of people in a household. So population distribution, and here you see 6 different samples of household size. So if we were to do a random sample of people in this population, one sample would be right here. And you can see it's not exactly matching the population distribution, but man, the shape is still the same. It's unimodal. It's skewed to the right. If we do another sample, again, it doesn't match this one perfectly, but it's unimodal, okay, and it's skewed to the right. Same thing with this one, and this one, and this one, and this one. They're all unimodal. They're all skewed to the right, okay? And so, sample distributions may resemble the population distribution. Closer to the population, the closer the population is to the actual, the closer the sample is to the actual population, probably depends on how many people were actually in the sample. In other words, if we have a large sample, it's going to look closer and closer to the actual population distribution. So that's 2-4. Tomorrow we're going to get into misleading graphs, and we'll work on the homework assignment for tonight in Math Excel, and then we'll come back tomorrow and work on assignment number 5.